All right, welcome back to the deep dive. Today we're shifting gears a bit. We're going beyond, those amazing engines that we always talk about, and really getting into what makes Porsche such a technological powerhouse. We're going to deep dive into their innovations in suspension, aerodynamics, braking, and even take a peek at how they're moving into the world of electric.
Yeah, I think it's often overlooked. People get caught up in the flat sixes and the turbos and the horsepower figures and the lap times, but the real genius is in how it all works together. And I think a great place to start is with suspension. Going all the way back to 1931 with Ferdinand Porsche's patent for the torsion bar suspension.
So this was instead of the typical leaf springs, right? They
Yeah.
were using the twisting force of metal bars. It was a lighter system. It was more compact. And I mean, by 1955, they were advertising better traction, less body roll, smoother ride, even increased safety. Perfect yet simple, they were saying.
Yeah, perfect yet simple. I love that.
It's so Porsche right.
Mhm.
And this really became a defining feature for them, from the 356 with the independent front and the transverse rear, all the way to the early 911. It was only with the 964 generation that they finally started shifting towards the coilover suspension when they introduced all-wheel drive models.
And that's a good illustration, I think, of how they're willing to adapt to new performance demands.
Yeah.
They didn't just stick with torsion bars because it was a Porsche thing. They went with coilovers when the all-wheel drive systems demanded it. But sticking with that suspension theme, let's talk about the 977 Porsche 928 and the introduction of the Weissach axle. I think this is where things get really, really clever.
Okay, so the Weissach axle was designed to combat some handling instability that would occur during cornering and braking. The rear wheels would kind of toe out, which could
Ugh.
lead to oversteer.
Yeah.
So how did they fix this?
Well, they use the natural give in the rubber bushings to actually create a slight toe-in effect under those forces. And this had a really dramatic effect on stability. Really quite clever and a fundamental concept that's, still influencing axle design today.
Mhm.
And it even made its way into the 993 generation 911 later on.
So the 993 is interesting because that's when we saw the introduction of the multi-link rear suspension.
Yeah.
What did they achieve with that more complicated system?
So with the multi-link and all its 8 bushings, they could really fine-tune how the wheels move. So this meant better handling, and it also meant a more comfortable ride because you're better isolating the cabin from the road.
Yeah.
And speaking of that, Porsche Classic actually reissued those 993 shock absorbers with Bilstein. They actually improved them. So it shows how significant that generation was. And of course, we can't forget that the 993 also pioneered those upside-down front shock absorbers
Oh, yeah.
for better handling of lateral forces.
All right, so we've talked about multi-link, we talked about the Weissach axle. What about something really extreme, like the warp connector suspension? They developed that for that record-breaking 911 volcano climb.
Yeah, Edith, the volcano climbing 911. That was a project. So the warp collector was really a solution for some extreme terrain. It's the system that connects all 4 wheels, and they have central springs and dampers. It's almost like having solid axles, but with near zero body roll.
Oh.
So you can imagine how that would help keep those wheels on the ground when you're climbing a volcano.
Yeah.
And this system, it has its roots in motorsport, actually. It was originally intended for the RS Spider and even considered for the 910 hybrid. So again, just a testament to how versatile and capable Porsche engineering can be.
Yeah. So moving from keeping the car planted on the ground to moving through the air, let's talk aerodynamics. Even as far back as the 1948 Porsche 356. We saw them paying attention to the shape of the car, its aerodynamic properties, and that really influenced the form of the 911, which itself has, design cues taken from aircraft wings.
Yeah, it's incredible when you look at it how early on they understood the link between reducing drag and going faster. And of course, that was especially crucial for motorsport.
Right, and that philosophy evolved into what they call Porsche Active Aerodynamics, PAA, which is all about having those aerodynamic elements adjust on the fly.
Hmm.
And a good example of that is the 964 Carrera. It had that retractable rear spoiler, it would pop up in speed for stability and cooling.
Yeah, I still love seeing those spoilers deploy.
Oh, yeah, me too. And of course, Porsche has given us some truly iconic spoilers over the years. There's the 1972 911 Carrera RS 2.7, the ducktail. It was actually the first production car spoiler designed to provide downforce.
So recognizable.
Oh, yeah. And then you had the even larger whale tail spoiler on the 911 Carrera RS 3.0 in 1974.
Yeah.
And of course, more recently, we have the taco wing on the
Yeah.
96.1 GT3, which is, more subtle, but still very effective.
Yeah.
And then there's the swan neck design that's on a lot of the track-focused cars like the 911 RSR and the GT3R.
Yeah, those swan necks they're really interesting. They're designed to allow for a lot of adjustability, but also to provide smoother airflow under the wing. So you get more downforce without having to add a lot of weight.
So how does Porsche actually develop these designs? Well, they've been seriously committed to wind tunnel testing since the 1960s.
Mhm.
They started with scale models. I mean, there's a famous picture of a 1/5 scale model of the 935/78 Moby Dick being tested at Stuttgart University.
Oh, wow.
But eventually they built their own wind tunnels at Weissach. First they had a 1/4 scale tunnel, then full size, and then in 2015 they opened an aeroacoustic wind tunnel.
Yeah, they really invest in understanding airflow, and these days they can even simulate the effects of airflow with computers, but there's still no substitute for real-world testing. They have these huge conveyor belts in the tunnels. They can get the cars up to 300 kilometers per hour. It's really quite impressive.
So we've gone from making the cars go fast to making them stick to the road to making them slice through the air. Let's talk about stopping. So the early 356, it actually had drum brakes, but they were pretty large and effective for the time.
Yeah, and they actually used finned aluminum and steel liners in those drums to save weight and help with cooling.
Clever.
Yeah.
But they eventually transitioned to disc brakes in the late 1960s. In fact, the last few years of the 356 production actually had disc brakes as an option, and the 911 came standard with four-wheel disc brakes right from the start.
Yeah, and the 1962 356 B Carrera 2 was actually the first series production Porsche to be fitted with disc brakes as standard. They were an annular design, but a really important step forward.
So another key development came in 1965 when they developed internally ventilated disc brakes. This was for the 906-8 Bergspider, that race car. And it was really necessary because the brakes were getting so hot.
Yeah, you can imagine. So these internally ventilated discs, they had this double-walled design with channels for air to circulate through. It was a much more effective way to keep those brakes cool. And it wasn't long before this technology made its way onto the road car. In 1966, the 911S became the first production car in the world to be fitted with internally ventilated disc brakes as standard. And that's something we really take for granted now because it's pretty much standard across the industry.
Right. And on top of the discs themselves, Porsche has also continually refined the brake caliper technology.
Yeah.
The early 911S had those aluminum calipers, but they could get a little spongy under heavy braking.
Yeah.
So they redesigned the calipers to be stiffer. They went to a single-piece design. They started using cast iron. Then with the 1977 911 Turbo 3.3, we saw the introduction of four-piston calipers, and that design was actually derived from the 917/30 race car.
Yeah, and then things really took off from there. In 1996, the Boxster came standard with monoblock aluminum calipers. They were much better at dissipating heat, which meant better performance. And of course, now we have cars like the Cayenne Turbo S with those huge 10-piston front calipers and ceramic discs.
Yeah, those things can really bring you to a stop.
Oh, yeah, they're incredible.
So we've also seen the integration of ABS, the anti-lock braking system. It was first offered as an option on the 1983 928S and then later on the 1987 944 Turbo.
Yeah, there was a little bit of pushback from some sports car enthusiasts at first. They felt like it was taking away some of the control. But the safety benefits of ABS are just undeniable. Being able to maintain steering control while braking hard is just so crucial.
Right. And then in 2001, Porsche introduced the Porsche Ceramic Composite Brakes, or PCCB. They were first offered on the 911 Turbo and the GT2.
And those are amazing. They're 50% lighter than cast iron brakes. So you get a huge reduction in unsprung weight, which improves handling, and they're also incredibly resistant to heat and wear. The downside is that they're not machinable and they're very expensive to replace. But if you're looking for the ultimate in braking performance, PCCB is the way to go.
So finally, let's talk about something a little different: regenerative braking in Porsche's electric vehicles, specifically the Taycan. So the electric motors in the Taycan can actually recover energy during braking, and in typical driving, they actually handle about 90% of the braking.
Yeah, it's pretty amazing. It's one of the key technologies that allows for those long ranges in electric cars. The Taycan Turbo S, for example, it can recuperate up to 290 kilowatts of power during braking, and that can actually increase the range by up to 30%. Yeah, and the transition between regenerative braking and the hydraulic brakes is really seamless. They have all these sophisticated algorithms that manage that. And just to keep those hydraulic brakes working properly, they'll actually engage them periodically just to clean the rotors. It's pretty clever.
Yeah, it's amazing how they've managed to integrate those two systems. And it's not just the Taycan either. The Cayenne e-hybrid, they've actually managed to boost the recuperation power to 88 kilowatts in that car as well.
Wow. So they're really committed to getting the most out of this technology.
Absolutely. So I think it's safe to say that Porsche's journey is one of continuous engineering excellence. They're always pushing boundaries, but they never forget their heritage.
Yeah.
And these innovations, from the mechanical systems to the advanced electronics and now electrification, they haven't just shaped Porsche. They've shaped the entire automotive landscape.
Yeah, I completely agree. And it makes me wonder, what's the next long-standing automotive norm that Porsche's gonna challenge?
Yeah. What are they going to come up with next?
It's exciting to think about.
All right. Well, on that note, that's it for today's deep dive. We'll see you next time.
See you next time.